An object at rest remains at rest, and an object in motion maintains its velocity unless it experiences a net force.
The skateboard keeps moving at the same velocity until a net force my foot stops it. An object, the chair, stays at rest when not being affected by a net force.
The imbalance force acting on an object equals the object's mass times the acceleration. There are two cars that are pushed at the same time. Each car is pushed with the same amount of force. Notice that the smaller car that has less mass moves faster than the car that is bigger and has a bigger amount of mass. The two balls are pushed at the same time. The same amount of force is applied to both balls. Since the tennis ball has less mass, it rolls faster and it rolls a longer amount. The other ball rolls slower and rolls less distance than the tennis ball. For every reaction force, there is an equal and opposite reaction force. When we throw the ball against the wall, it bounces back, showing us how every action has an equal and opposite reaction. For every kick we give to the punching bag, it comes back to us, demonstrating that there is an equal and opposite reaction for the kick. The property that a moving object has due to its mass and its motion, a quantity defined as the product of the mass and velocity of an object. When the two balls that are the same size collide against each other, they have the same conservation of momentum. When the baseball collides with the tennis ball, the one with the bigger mass will push the other one further away, making its conservation of momentum larger. Two toy cars crash against each other. When they crash, one bounces back more than the other and has larger conservation of momentum due to the fact that one has more mass. An attractive force that acts between any two objects.
When Paulina jumped, the gravity put her down and back to the ground. If there was no gravity, she would stay floating instead of landing back on the ground. When you tip the cup over, you can observe how the water moves because of the pull of gravity.